On my left is Dr. Alexander Bassuk, who most recently has been named the chair of pediatrics. Alex has spent the last 14 years working as a pediatric neurologist and researcher, and he studied genetic and molecular mechanisms in epilepsy, autism, inflammation, retinal diseases, and traumatic brain injury. And Dr. Bassuk is joined on my right here by Dr. Gordon Buchanan, who's Associate Professor of Neurology and currently holds the Beth L. Tross Epilepsy Professorship. Dr. Buchanan has spent 7 years here in Iowa as an adult neurologist and a researcher with a special focus on sudden unexpected death in epilepsy, otherwise known as Sudep. So let's move on. Dr. Bassuk, why don't you tell the audience, what your background is and how do you end up at the University of Iowa? Yes.
Well, thank you very much. And before I start, I just want to thank you for inviting me to this today, and thank you and Beth and your entire family for supporting us here at the University of Iowa. I mean, I think I'll let Gordon speak for himself, but we're all just so grateful for everything you've done for the University of Iowa and for patients with epilepsy. We really can't do it without you. So as far as my background, I did my college, my MD and PhD at the University of Chicago. I grew up in the Chicago area, and I did my clinical training in pediatrics and neurology at Northwestern University. And then I was there as a faculty for 3 years, and it was time to look for a grown-up job at the age of 37. And we had 3 kids, and we started looking around. My family's from Argentina. They're actually from a big city, from Buenos Aires, and my wife's family's from Mumbai, which is a big city in India. I kind of thought I was a big city guy, and we'd end up in a big city. But my wife grew up in Champaign-Urbana, and she said, let's look at university towns. And I ended up interviewing here at the University of Iowa, and I was just so impressed from the very beginning with the collaborative spirit. I mean, they're really, people had talked about in my interviews about collaborating with other people, but being in a big city the whole time, I really hadn't had that experience. And from the very beginning here at the University of Iowa, I could see that people really, there weren't any silos. Physicians worked with engineers, different departments worked with each other. Everybody had that common goal of getting things done, working together, and advancing knowledge. And that was just really exciting for me. And there really was just such a great tradition of science and research in the hospital, in the pediatrics program and in neurology. So it was just very exciting. So when it was time to make a decision, great place to live, great place to raise a family, and an incredible collaborative environment. And it was really just the best decision we made for myself and for my family. We've been here for 14 years. My kids all went through the public school system. My 3 kids, 2 kids graduated already from the University of Iowa. I have my 3rd child just started as a freshman here at the University of Iowa. Even my wife is getting her master's. She'll be finishing this year from the University of Iowa. So I unfortunately am the only one without a degree in the family from the University of Iowa, but
we can work on that.
There's still time. So I'm just a giant fan, and it's just been an incredible experience and honor. And coming here as an assistant professor, working my way up the ranks, just been so lucky to collaborate. I have collaborations in adult neurology, collaborations in biology, and people throughout the institution. And then just 6 weeks ago, I became the department head of pediatrics. And now it's an opportunity to continue with the research that we've been doing, but also help the entire institution grow. So that's the background, and I feel like I'm just getting started.
Yeah, and don't let Alex slow play all of you on what it means to be chair of pediatrics. He told me last night that there are 750 people now that he's responsible for. So it's an enormous job, but I'm sure he is capable. Gordon, I think you can match.
We can try. We can try. That was quite a nice story there, Alex. Nate, I also want to thank you and Beth, your family, for everything you've done for us here at epilepsy and neurology at Iowa. As you know, the position you created within neurology, the beginnings of it was part of how I got recruited here in the first place. Since that position was open, we were recruited to look at that position. And as you know, I'll go back and talk a little bit about my background in a second, but as you know, they were also recruiting my wife, who's a child psychiatrist and is now the head of child psychiatry here. So it became a really nice opportunity, unique opportunity for two jobs that were really uniquely suited to both of us in one place. So that was really created an amazing opportunity. So I'm similar to Alex. I'm from the Chicago area. I grew up in the northwest suburbs. Similar to Alex's wife, I guess. I spent a lot of time in Champaign-Urbana. I did undergrad there and MD PhD. I was there for 13 years. So all of my degrees are from there. I met my wife there. We moved to Yale to do our residency and fellowship there in the Northeast. And we stayed there for a while for faculty. Both of us stayed for several years. And then we were recruited here. And, similarly to how Alex described his wife suggesting looking at the Midwest town, we love Champaign-Urbana. And we really also thought that Iowa City would have a lot of parallels to Champaign-Urbana in terms of the community and the people and the ease of living. And, that's certainly been really true. What we came to learn, though, was that the science and neuroscience and the clinical care here is really top-notch, and it's an incredibly collaborative environment. I also have many collaborations. Mine tend to be mostly focused in pharmacology and neuroscience, but we have quite a few outside the university as well. But the university's made it very easy to maintain these collaborations and really advance our science. So I also have kids, and it's been a great place to raise the kids. Lots of opportunities. They're going through the public schools on the other side of town for Alex's kids, and they're a little farther behind, but that's not because of ability, it's just because of age. But they're doing, but it's been a great place. It's been a great move for us.
So you both have mentioned the word collaboration. So Gordon, would you say that that's one of the best features of working here at in Iowa City at the University of Iowa? And can you expand, give us an example of a collaboration that you do with other departments?
Sure. It is an incredible feature of working here at the University of Iowa. When you're in your lab, you have the resources that you have, and if you have a new idea, you may not be able to pursue it with the resources that you have. But somebody down the hall might have something. And here, I know without a question, I can go ask that person to help me with the experiment, let me borrow their equipment. There's also, through the Iowa Neuroscience Institute, there's some incredible infrastructure set up to really ease these collaborations. We have a weekly collaborative meeting where we get together to discuss ideas, and that can, if you're not sure who to ask, that can sometimes things just come up there organically, and collaborations are born. I collaborate quite a bit with people that develop other mouse models, and they might develop a mouse that has some sort of sleep deficit or a seizure disorder or is experiencing seizures. And I'm very well equipped to assess those sorts of phenotypes in animal models. So I'll help them, look at those kinds of things. And I've been looking, not to get too into the weeds yet, but, we've been delving a little deeper into circuit mechanisms and looking at how different parts of the brain interact using, recording techniques and imaging techniques within the brain in living animals. And so I wasn't set up to do that kind of work, but people nearby were. And so we've really advanced some lines of research, and it's leading hopefully to additional funding and future publications.
Alex, for you, collaboration, what's been the best the best collaboration you've had while you were here?
Well, there's so many. I'm going to tell two stories. One are from early on. So it was early on in my career here, and we all of our research starts with patients. So often we start with families that have epilepsy, for example, and we try to figure out what is the cause of epilepsy in the family. So we try to figure out what the genetic cause is, and once we figure out that genetic cause, then we go and model it in different systems, including different animal systems, as Gordon was talking about, to try to figure out what is going on with that gene in epilepsy. And then if we can figure that out, then we can say, well, how can we do something about it and try to cure the epilepsy? So the initial collaboration was that there was a physician scientist here at the University of Iowa when I was being recruited here. His name is Hatem El-Shanti. He had a family, a large family, over 100 patients collected with epilepsy, where we had, where he suggested that I work with him to find the cause of epilepsy in his family. Now, he was recruiting me and very enthusiastic about my coming to the University of Iowa, despite the fact that he was leaving the week after. But that's how much he loved the University of Iowa. He was leaving to go to be the head of the Shafala Institute in Qatar, and asked me to work on this project. He left me this project and wanted me to come and do to work on that at the University of Iowa. So that's the initial collaboration, and that actually got me started in epilepsy genetics. So we found the cause of epilepsy in that family, but I wanted to figure out how it works once we found the cause. So I needed to use a mouse model first, and this is going to sound really dumb, but what I actually did was I went to my computer and I Googled epilepsy mouse University of Iowa, and a name came up, John Wemme. John Wemme, that sounds familiar. I looked at where his lab was, and at the time it was one floor above mine. So I went upstairs and I knocked on the door and I said, "Hey, John Wemme, I'm Alex Bassuk. I'm new here. I heard you know about epilepsy in mice," and it turns out that they were doing electrographic recording. So putting, basically in humans, we put little stickers on the head and figure out what the electrical activity in the mouse is. They were doing it in the lab. They were doing it with a neurosurgeon. So John Wemme is a psychiatrist. He was doing this work with a neurosurgeon. His neurosurgeon taught my graduate student how to do this technique. And we figured out what was going on in this mouse model of epilepsy. And then, just because I was really into this Google collaborative spirit, I Googled, it turns out that the gene that we found has been described in fruit flies, but nobody had ever looked at epilepsy in these fruit flies. So just, I thought, worked last time, we'll try it again. University of Iowa fruit fly epilepsy. And it turns out that the person who first described epilepsy in fruit flies, Cheng-Fang Wu, is here at the University of Iowa in the Department of Biology. So I talked to Cheng-Fang Wu and his collaborator in that same department, John Manick, and we developed a fruit fly model of epilepsy. And the nice thing about the fruit fly is that, we can get literally tens of thousands of them and test lots of different drugs in them very quickly. So all of this was, just, unexpected riches here at the University of Iowa with a little help from Google. So I'll leave it at that, but I can tell many stories about collaboration, and it's just been absolutely wonderful.
So along those same lines, for me touring both your labs the last day or so, I was very impressed with the amount of diversity, or call it the international flavor of the people that are in your labs. Gordon, do you think this collaboration attracts people from around the world, to Iowa? We're not California, we're not New York, we're Iowa, but yet we're attracting people from all over the world. Do you think that's a part of it?
Yeah, I think, collaboration, I think, is a part of it. I think in general, overall, the opportunity is really a fantastic opportunity for trainees here. And I think, people of all backgrounds recognize that. And I think we really do try to support and foster people, from all backgrounds.
Yeah, and Alex, today, same thing.
Yeah, our lab, we have, we're very well represented. We have, people, Argentine, Mexican, Chinese, Indian descent, Egyptian, in our group. And I think, I think this is true. I know it's true in Gordon's group as well. And Gordon and I have talked about this and actually are on different panels that committees that just talk about diversity, equity, and inclusion. We are better. It's not just the right thing to do to focus on these issues, but it is better for our science when we have a diverse group of thinkers coming at this from all different backgrounds. So it is absolutely a priority for us, and really we value our diversity in our labs.
Yeah, it seems to be very important. I know this is very hard, and your careers, both of you, are still very early. But can you point to any one thing, not necessarily any breakthrough, but the one thing that you really would think about looking back that you've enjoyed the most in your career? Yeah, tough question.
No, it's not. I mean, there's so many things. It's not. I don't have a hard time answering the question. I think right now, I will just tell you the thing that I'm really enjoying is mentoring the next generation of scientists. So I have opportunities to do that now in my new position, especially at many levels. So from really even high school students, college students, medical students, residents, graduate students, postdoctoral fellows, junior faculty, and we have the next generation. We're in good hands. The next generation really is better than we are, which is what we want. And there's so much excitement about science and about the new technologies that are out there. And as you saw in our lab and you saw in Gordon's lab, I mean, we're going to cure epilepsy. We're going to have multiple cures for epilepsy, but it is happening. And it's a related point, but when Gordon and I, I'm a little older than Gordon, but when we trained in neurology, there were diseases where essentially if you got that diagnosis, it was a death sentence, even in a kid, that if you were diagnosed with this disease, it meant you would never walk, you would never eat on your own, nothing. And we have kids with these kind of diseases now that with a single injection of a gene therapy are cured of that disease, which is just seems like science fiction. And it's this next generation of students and researchers that are bringing. So that's the seeing those new innovations and helping the next generation achieve those dreams. That's been the most exciting.
Gordon, I know that you don't need any artificial motivation to do what you do. Told me once that on a Saturday morning you'll go to the lab in the morning and you'll come home for lunch, and your wife will go to her lab on Saturday. So motivation isn't a lack of motivation is not a factor. But in the middle of January when it's 10 below and there's snow on the ground, what really gets you going in the morning? What something that really drives you?
Yeah, that's a good question. It's it's not a single thing. It's a mix. I was going to say that the thing that I enjoyed the most was exactly what Alex said in mentoring, and I think people that know me will know that resonates. But it's a little bit like being a kid and wanting to just see what happens. Doing the experiment, getting I'm a little less doing the experiments myself these days, that I'm sure Alex knows. But getting the result, hearing from the student, knowing what they did, what they found, thinking about what to do next. That's really exciting. And then thinking about how it will apply to patients. Will this lead to a cure for epilepsy? These are exciting possibilities. And, and really having the patient, we haven't really talked about this that much yet, but, we both have patient care aspects. And taking care of, the Iowans with epilepsy is really, it's really amazing. It's, very fulfilling. That's the word I'm looking for. And, to think that we're really at the heart of it, we're doing the science that we do to try to help these patients, try to come, something that will cure epilepsy or reduce side effects from medications, make medications more efficacious. And in my case, try to prevent seizures from being fatal.
Well, since you mentioned the clinic, talk to us more about being a clinician and what, how many patients, you might see, or the department as a whole, and, you talk about, the lack of neurologists, outside of the larger cities.
Yeah. Yeah, so this is a problem in Iowa. It's one of the underserved states for neurology and especially for subspecialties like epilepsy. Most of the neurologists in Iowa are in Iowa City, and we have a huge catchment area. I usually see patients on Mondays, and on a given Monday, I'll see patients from Sioux City or Mason City or even near Rochester, or even near from the Chicago area. They'll come all the way out here for their epilepsy care. I think in the clinics, the outpatient clinics, we probably see as a division about 1,000 patients per year through the outpatient clinics. We have a 9-bed inpatient epilepsy monitoring unit, so we probably bring through something like 450 to 500 patients through that every year. And then we're the only level 4 epilepsy center, in Iowa, and a little bit beyond, beyond Iowa. The circle is bigger than just Iowa, and we probably do something like 20, 25 epilepsy surgeries per year. So actually taking patients with refractory epilepsies through to a surgical intervention.
And the percentage of people with seizure disorder who are not helped by oral medications is
About a third.
Yeah, that's a big number.
And as you know, those patients are at the highest risk of dying suddenly and unexpectedly from their seizure.
Alex, I think you told me yesterday a number that really blew me away. The percentage of, I think it was children that will suffer some sort of seizure. In their young lives, and that number, what that percentage is.
Yeah, so I mean, epilepsy and seizures are very common in kids. So something, depending on how you count it, around 8% of kids will have a seizure during childhood. And about 1% of kids will have epilepsy during childhood. So, what that translates to 700,000 kids, about a little more in the state of Iowa. That's 70,000 children. I'm sorry, 7,000 children with epilepsy, 7,000. And we see a lot of those kids. We, have an active roster of patients that we're following because they're sick enough that they need to see our specialists. 1,000 kids with epilepsy at any given time. And just to give you perspective, when I came to the University of Iowa 14 years ago, I was the 3rd pediatric neurologist in the state of Iowa at the time. We've grown the division to when I took over the reins about 3 years ago of the division of neurology. We were 7, we are now 12. The first thing I did was add epileptologists, and this was shortly after we met. But we went from having 1 pediatric epileptologist in the entire state of Iowa to now having 4, and a dedicated nurse, and a dedicated clinical coordinator, thanks in large part to your work, so that we really can do the full service treatment of having specialized epilepsy care that includes working with our surgeons for epilepsy surgery, enrolling kids in clinical trials, and working with the adult epileptologists at joint conferences about how to best take care of these kids. So we've come a long way, but there's a huge need.
No doubt. Gordon, you mentioned sudden unexplained death. Can you explain, kind of flesh out what Sudep means? What are maybe some of the factors for everyone? Because I think it's very much underappreciated.
Yeah, sure. And today actually happens to be Sudep Action Day. So, there's my plug, got that in. So, yeah, Sudep is really the most devastating and unfortunate consequence of epilepsy. It's, as the name, as the name suggests, it's sudden, unexpected death in patients with epilepsy. We believe that it happens following, immediately following a seizure. We don't know everything about Sudep yet. Sudep is often unwitnessed. And so because of that, we don't know all the features that go along with Sudep. We're really trying to improve awareness so that people know that, seizures can be fatal. We think the best thing we can do right now is to really properly, as well as you can, control your seizures. So taking your medications properly, taking them, the number of times a day you're supposed to take them the appropriate doses, the right combinations, really trying to be aggressive if you're continuing to have seizures. A couple of the features that have been borne out of some human studies and also animal studies are this sequence of events. We think that seizures lead to probably primarily a respiratory demise of some kind, a respiratory arrest that ultimately leads to death. There probably will be cardiac consequences, in between. But a lot of us think that the breathing is the first thing to stop following seizure. Another important feature, and is really the base of a lot of the work that I do in my lab, is that Sudep tends to happen at night. And so we're very interested in how sleep state affects whether or not a seizure will be fatal. And we're also interested in time of day or circadian rhythms. Everybody has this biological clock. So circa dia means about a day. And we think that this may somehow regulate whether or not a seizure will be fatal. So we have a lot of ongoing research projects in that regard.
And listen, something that very much needs to be studied further. Alex, one of the times that we met, you told me about using fish, if I'm not mistaken, and in drugs that have been on the market, prescription medications that have been on the market that may have uses other than what they were originally developed for. Why don't you tell us about that?
Yeah, thanks. So Nate knows me long enough to know that I'm maybe not the most patient person in the world. And, I'm 52 now, and I really I love what we do in the lab, and I love learning. And when we find out something new, we were just talking about this, there's a moment where we know something that no one has known before that is now a fact. And that by itself is very exciting, but it is really, for me, it isn't the only reason I'm doing this. I want it to help patients. So we started thinking a few years back, how can we get to cures, treatments more quickly? We decided to use this approach called drug repurposing. And the idea here is to use drugs that are already FDA approved. So any doctor could prescribe it, but aren't yet tested in epilepsy, and see, could those drugs work for epilepsy? So the question is, how do you figure out which are the ones that you should try, because we have thousands and thousands of drugs. So we actually did a series of experiments that, again, it started with patients. So we actually, with our colleagues in neurosurgery, Matt Howard, the head of neurosurgery, and others, we actually got tissue from patients with epilepsy that had epilepsy that was so bad that they had to have a portion of their brain removed. And we were able to do pretty amazing electrographic, and Gordon does this himself, electrographic recording, so actually measuring the seizures during surgery, measuring parts of the brain that were having seizures versus parts of the brain that weren't having seizures. And we got to get tissue from the seizing brain versus the non-seizing brain. And then we did a very neat trick that involved artificial intelligence with our colleague in psychiatry, Jacob Michelson, who's a computer scientist, and asked the question, what happens to the seizing tissue genetically versus what happens to the non-seizing tissue genetically? Okay. And then we have this list of genes that went in one direction in the bad tissue and that went in a different direction in the good tissue, or the seizing versus the non-seizing tissue. And then we did another informatics trick where we said, okay, we have a list of all the drugs that exist. Are there drugs that give us a pattern that looks like the non-seizing tissue and looks opposite to the seizing tissue? That really gave us a narrow list of drugs that we knew could be anti-epilepsy drugs or anti-seizure drugs at the very least. So now we needed to test that. But it was a long list, and we wanted to test it in a way that you could do very quickly. So it turns out that zebrafish, you can test whether or not they're having seizures very easily. You can have hundreds of them in a tank. You can watch them. You can record their seizures. And in anatomy and cell biology, another department, we had a colleague, Rob Cornell, who had a zebrafish lab with a zebrafish tracking system. So we tested a whole long list of these drugs in a zebrafish, in actually 2 different zebrafish models of epilepsy. And we got a list of drugs that now we know have been FDA approved for other things, not for epilepsy, but could be now possibly work for epilepsy. And you heard today that we have a drug candidate, one that is our favorite right now, that has worked in 2 different models to cure zebrafish, 3 different models now to cure different kinds of mouse seizures. And now what we want to do is we want to take this drug, and again, an already FDA approved drug that people have been using for 30 years, and ask, can this drug work in people? So then it's time for clinical trials. It's kind of a long story, but again, we started with patients and we want to go back to patients.
Very exciting, actually. It really is. Gordon, this may seem redundant a little, but everything that you do and people that work for you in your lab, the university can provide all the funding for us. No institution can. So, briefly, how has philanthropy, changed the way, or given you, more advancements to your work?
Sure. Yeah. As you know, Nate, a lot of the work that we do, we write proposals and we submit them to funding agencies to try to get some funding to do a really discrete set of experiments. And you're really fairly limited to doing what you described there. And within the umbrella of these proposals, it's hard to take advantage sometimes of the collaborative environment. If you really have a great idea, you can maybe do a little bit, but it's really hard to run with a new idea without philanthropic dollars. Because this money is really often more open-ended. It's given, it's often made available to somebody to pursue more of a set of ideas and less specific experiments, and it really allows the flexibility to pursue those ideas, and then so that can be used to obtain preliminary data that would help set up another grant application to the funding agency like the NIH or something. It can also help to support trainees. It might allow us to bring in extra trainees than we would have been able to otherwise, and that provides an amazing opportunity for those people to advance their careers. So it's really vital. The money from NIH is great, but it's limited, and it's really essential to have the other sources of funding.
Alex, now that you're head of pediatrics, I would assume that the department does garner a lot of both public and private funding.
Yeah.
How does Iowa rank?
Well, in terms of philanthropy, I don't know how we rank, but it is a huge part of our ability to do all the things that we do. And we have incredible support for the Children's Hospital. Many of you in our audience, I suspect, are familiar with the Hawkeye Wave. But, the Center for Advancement here, it really lights up after every first quarter of a home football game, because the emotions that are aroused, and I've been now on both sides of that. I got to do this from the field on the last game, and I've been behind the glass in the hospital. I mean, that is just an incredible moment, and really that moves generous Iowans and people from all over the country to give to our Children's Hospital. And a lot of pediatric diseases are not funded at the same level as their adult counterparts. That's true for pediatric epilepsy. It's true for a lot of other pediatric diseases. So the philanthropy there really allows us to do things that we would never be able to do. And in the specific case of your work, I mean, we've just been able to go much more quickly and much more aggressively because of those funds. So it's an absolutely essential part of what we do, and we're so grateful to all of our donors, because we make every single one of those dollars count.
Yeah, and I've got to believe, and I don't think I'll get any negativity from either of you, that being here in Iowa City is very, very cost effective, as opposed to being maybe in some of the higher profile places. And you know, it's just a very good place to be, I would imagine.
It's an incredible place to be. It is very cost effective, but it's an amazing place scientifically and clinically. There are really there's not just some, there's a lot of really exceptional investigators here, and you know, it's just, we're having the opportunity to recruit more, and there's a lot of great sort of up and coming people. They're top notch, you know, kind of junior people. But yeah, it's really wonderful.
Yeah, and the donors, I mean, we just talked about the work that you and Beth has done has been amazing. But you know, we have this Iowa Neuroscience Institute that Gordon and I are both a part of, that was, I believe, mostly funded by a $45 million gift from the Carver Trust. And this has just allowed there to be an absolute nexus of a critical mass of neuroscience researchers from all over the world that have been able to come to Iowa. You know, who knew? But we just have an incredible group of neuroscientists that are collaborative and working together, and from all different areas: Parkinson's research, fruit flies, hearing research. I mean, just it totally without any borders or silos. And that's really all because of philanthropy. I mean, that would not have happened without philanthropic dollars.
I would think that when both of you go to national or international meetings, that you would stand tall. Say we're from the University of Iowa. No one looks down. That they probably very much look up at what both of you are doing in the whole Department of Neurology.
And a lot of people have been hearing about I mean, we haven't been to meetings lately because of the pandemic, of course, but even before that, a lot of people have been hearing about the growth here and are excited to hear about what's happening here in Iowa.
And the millions of viewers and listeners to the chat at the old cap, of course, will be millions will be glad to hear about.
And I think on that light note, I'd like to thank Dr. Bassuk and Dr. Buchanan for your time. It's valuable, and you spent a lot of time today over the course of the years with me, and I couldn't be happier with the work that both of you are doing on behalf of epilepsy research, and continue the good work, and that Iowa is and will continue to be a leader in the future.
All right, we have some questions and answers, it looks like.
Wow. Let's see.
I guess we have that provided answer.
Yes, we do. Okay, so this is for both of you. What are your thoughts on use of CBD for epilepsy? And I know there's one drug, Epidiolex, that has been approved by the FDA for certain types of epilepsy.
Sure. Yeah, and for those, I have some patients with those conditions. Those are, I primarily have Lennox-Gastaut, but there's also approved for Dravet syndrome and tuberous sclerosis. And it's for some of those patients, it's been very helpful. It's it's not a magic bullet, but it is has been very helpful for some of those patients. I have a couple of refractory epilepsy patients that have been very refractory to lots of medications. We've been able to trial this, and that's been helpful for them. I think I think the big thing is watching the formulations that you're using. It's really important to use a high CBD formulation if you're getting it from a dispensary or something, and a lower THC component. I think but in general, I think it's a little bit mixed. I don't think I have anybody that's done worse on it, but I have definitely a fair number of people that haven't gotten much better with it. And that's just from, personal experience.
And just, this is for, actually my add-on question. CBD does not have the psychoactive ingredients.
Well, that's what I was,
right?
yeah.
So before anyone in the audience gets the idea that, they can have a real good time.
Yeah, I think, I would echo Gordon's opinion and his experience. It's definitely not a magic cure-all. It may have applications in certain cases. We are actually, in pediatric neurology, our head of epilepsy, Dr. Michael Siliberto, is part of clinical trials for cannabidiol for different purposes. And that's actually thanks, our ability to arrange those clinical trials are actually thanks to your work. So we do want to continue to explore it. We're just, we really do have to do the science, and that includes clinical trials.
I really like this next question too. Do you find a genetic link between epilepsy, migraines, painless migraines, and stroke-like symptoms? Genetics, this seems to be a fascinating way to attack these diseases.
Yeah, I mean, the short answer is there's definitely a genetic link between those things. And there are specific genetic syndromes that involve a single gene where you can have multiple propensities in many of these things: epilepsy and migraine, migraine and stroke. And these have been actually described for decades. So there is sometimes some of us even refer to certain things like migrepsy, migraine and epilepsy, because and there are epilepsy syndromes, and Gordon is better at describing this, where the predominant form of seizure is a headache. There is a really close connection, and not coincidentally, some of the drugs that we use for epilepsy work for migraine and vice versa. So this is an active area of research. I don't know, Gordon, if you want to say more about that.
I would just say that, and for some types of epilepsy, maybe not the actual seizure itself, but the sequelae from the seizure, the mechanisms may be very similar to how migraine, at least how it propagates.
Gordon, earlier on, you mentioned that the University of Iowa is the only level 4 epilepsy center in the state. Are there other hospitals in the state that have lower levels of care, I guess would be the best way to put it? And what would the difference be? If you know about that?
Well, I think by definition, since we're the only one that's high, I guess the rest would have to be lower. But I don't actually know all the distinctions, but we are the only one that can are a full accredited epilepsy surgery center. That we can go all the way from seeing the patient in clinic to doing the outpatient workup with imaging and epilepsy monitoring to doing the neuropsychological. We're one of the top, I think, neuropsychological programs in the country, and then taking them through a surgical case conference, and then considering doing surgical EEG, where we implant electrodes in the brain to really try to find the focus, and then taking a patient through to surgery, resection, where we can provide tissue for the kinds of experiments that Alex is doing.
And we're really, because we're a level 4 center, and because we are the University of Iowa, and we're so invested in research, we're really doing things that really almost no one else has. So, for example, Aaron Bose, who, if you ever watched any Big Ten games, I think our audience might do that. He's part of the University of Iowa Big Ten commercials. You'll see a doctor putting a paddle on someone's head, and what that paddle is a really strong magnet where we can, basically turn off a little part of the brain in a directed way. And we actually use that for epilepsy to figure out before the surgeons go in what particular parts of the brain are going to be sensitive to the surgery, to either avoid or target those particular areas. There are very few places in the country that are doing that. And we're doing it for epilepsy. We are doing it we also use it for depression, again, talking about the connection between different kinds of neurologic disease. And then we're also using that same technique. So Dr. Bose, who was a native Iowan, went to school here, then went to Harvard, and we stole him back here. And now he's the division director of pediatric neurology as of about 3 weeks ago. He took over my position. And that was one of my first recruits. But he's actually doing research with this technology as well. So that's, you have to be a level 4 center and have the surgeons, the radiologists, the social workers, the psychiatrists, the psychologists, everything in place in order to do that kind of, those kind of treatments and that kind of research.
Our last question, I guess I'm going to do some interpretation. The questioner wants to know, is there any collaboration, here we go back to collaboration again, between the Department of Neurology and students attending the university that have seizure disorder and epilepsy?
You want to take that one? Or do you know?
I'm not exactly sure what the what it means, but we'll take it however we want it to mean. So I can tell you, as pediatric neurologists, we work with all of the schools to educate teachers and other people in the classroom about what a seizure looks like. We have books for our younger children, you know, taking seizures to school where they can actually bring, it's a beautiful picture book, and they can show, the teacher can read it to the class and say, this is what a seizure is, this is what you should do afterwards, this is what it looks like. At the university, you know, we are completely committed to diversity and inclusion, including people with disabilities or different abilities. And we, you know, without disclosing, I can tell you, because my department is big enough, we have people with epilepsy that work in our labs. And in fact, they are often a very highly motivated group of individuals, and we are very encouraging people with all kinds of diseases or different abilities to be part of our laboratories and of our clinical activities.
And I mean, in terms of if this means for college students with epilepsy getting care, we certainly see those patients in our clinic. We see a lot of university patients. We probably tend to see them more on the hospital side than they are treated, I would guess, in the student health, because a lot of times it's a little bit more complicated, maybe. But yeah, I echo. We have had a lot of students with epilepsy, or certainly students that have family members with epilepsy or friends with epilepsy, and it really, because of that, they gravitate to our research programs to study these things.
And I think with that, we will end this whole chat. Both of you have been very generous with your time, and hopefully the audiences come away a little brighter, a little smarter. So thank you everybody here on the call.